Hello students, in the previous video we saw how FIFO page replacement works. We also found how to decide on page faults. Okay, so if you go through the previous video, I had written a cross sign for all the page faults. So whatever you can see in blue here is actually page fault. So if this problem is asked to you, you will have to find the number of page faults. So in this case, the number of page faults is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the number of page faults here is 15. It is, I'll write it as F. The number of page faults is 15. And what about hit? It is 1, 2, 3, 4, 5. So we have 5 hits. Okay, if you add this should give you the number of pages in the reference string. Yeah. Okay. Now, I had also mentioned you point, that is, there is a anomaly called as Belladis anomaly. So here this graph shows. So initially I told you that if you increase the number of frames, then the number of page faults will decrease. Or if you try to decrease the number of frames, then the number of page faults increase. But there is a condition in FIFO, that is, sometimes when you increase the number of frames, the page faults also increase. So let's see here, 1. So definitely at 1, the page faults have increased, okay, because the number of frames are very less. At 2 also it is consistent. At 3, as in you have increased the frames, the page faults have reduced. It's a good sign. But at 4th frame, you have increased the number of frames, but then the page faults have increased. So this is a Belladis anomaly. Now again, you have increased the frame size and the page faults have decreased. Again, a good sign. But then thereafter, even in spite of increasing the frames, the number of page faults are consistent. So this kind of feature in FIFO is called as Belladis anomaly. Now we will move on to the next page replacement technique, which is optimal algorithm. Okay, so the idea behind optimal algorithm is you will have to replace the page that will not be used for the longest period of time. That is, in the FIFO, you scan to the left, right? But here we will have to scan to the right, because the one that is not going to be used for the longest period of time is to be searched in the right hand side. So that is the idea behind optimal. Okay, so let us take a problem and then try to solve it. Okay, so here also we have taken the same string, okay, reference string. So as you all know, the reference string is given to you all and the frame size is given to you, which is 3. So initially 7 is searched in the main memory. It is not in the main memory, but it can be allocated because it is free frame. 0 is not in the main memory. Okay, so it is a page fault, but 0 can be given a free frame. 1 is not in the main memory initially, so that's a page fault, but 1 can be given a free frame. Now, at this second page, okay, so there is no free frame that is available, so you will have to decide on which page to be replaced. So as I said, optimal is the page which will not be used for the longest time in the future is to be replaced. Okay, yeah. Now look at this. Now coming to 2. Okay, so 7, 0 and 1. 7, 0 and 1. And you will have to choose the one which will not be used for the longest period of time. So if you scan to your right here, then check which one is going to be used in the future. Okay, so 0 is going to be used okay, currently in the later part, and then 1 is going to be used after it, and but 7 is going to be used at the later point of time. So you can replace 7 with 2. Okay, so this is what is optimal page replacement. You have to scan to your right and check for the page which will not be used in the near future. Okay, now coming to 0, yeah, in this 0 is already in the main memory, so that's a hit. Coming to 3, 3 is not in the main memory, so it's a page fault, and you will have to now decide which page to replace with 3. Now check for 201. Fine. So 0 is to be used in the current future, and 2 later, but 1 at the longest time. Okay. So you can replace 1 with 3 here. Coming to 0, the next page, it is already in the main memory, so that's a hit. Then what about 4? 4 is not in the main memory, so that's a page fault. Now comparing 2, 0 and 3. 2, 3 and 0. So 0 is used in the later point of time. So you replace 0 with 4. The next page, 2. It's in the main memory, so it's a hit. 3 is also in the main memory, so that's a hit. What about 0? 0 is not in the main memory, so that's a page fault. And which one to decide to replace? 2, 4, 3, right? So we will see 2, no. 3 also no. What about 4? Yes, because 4 is not going to be used at all. So we will replace 4 with 0 here. Next, 3. It's a hit because 3 is in the main memory already. What about 2? 2 is also in the main memory already, so it's a hit. What about 1? Not in a main memory, so that's a page fault. Now, which one to replace? 2, 0 or 3? 2 is to be used here, 0, but 3 nowhere to be seen in the future. So you replace 3 with 1. What about 2 here? In the memory, so it's a hit. Sorry guys, it's a hit. What about 0? It's a hit again. What about 1? It's in the main memory, so it's a hit again. What about 7? It's not in a main memory, so it's a page fault. And which one to replace? 2, 0 or 1? 0 and 1 is going to be used in the near future, but 2 is not, so we will replace 2 with 7. Okay. What about 0? It's a hit because it is residing in the main memory. What about 1? That is also a hit, so it is residing in the main memory. So if you count the number of page faults, we have 1, 2, 3, 4, 5, 6, 7, 8. We have totally 8 page faults, and then we have how many? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 number of hits here. Okay, so this is how you find the page hit and page faults. But there is one problem with optical page replacement. It is nearly impossible to know which pages will be needed in the future, right? You will not know the future cases. So this is not a solution that is implemented in practical sense. Okay. So, but this is the best when compared to FIFO, because the number of fault rates are lesser here compared to the FIFO technique. So this one cannot be used practically, but we can measure the algorithm's performance based on optimal algorithm here. That is used for measuring how well your algorithm performs. Okay, so we can use it for that purpose, but this can't be implemented in practical. Thank you guys.